Hello class. In this video we're going to cover chapter 2 that discusses cost behavior, operating leverage, and profitability analysis. Let's get started. On the next page, let's talk about cost behavior. Now, cost behavior is how the cost actually behaves as to some level of activity. And so you can see we will discuss fixed cost, and then variable cost, and then mixed cost. Now, in fixed cost, here's an example the book has. Let's say there is a company that promotes rock concerts, and it's thinking about paying a band $48,000 to play a concert. So the $48,000 is a fixed cost. So no matter how many tickets they sell, they still will pay the band $48,000. Now, the thing about identifying a fixed cost is that the total cost does not change as the level of activity changes. Here, the level of activity will be the number of tickets sold. So whether we are going to sell 2,700 tickets, 3,000 tickets, or 3,300 tickets, we will pay the band the same amount of money no matter what, $48,000. So this is a true fixed cost. The total cost does not change with level of activity. Now, one thing that could be confusing is when you compute the fixed cost per unit. Total cost is $48,000, but per unit it will differ, okay? So if you sell only 2,700 tickets, you would divide the 2,700 into $48,000, and the cost would be $17.78 per ticket. Now, at the 3,000 level, since you're going to spread the $48,000 over more tickets, the cost will go down per unit. So $48,000 divided by 3,000 tickets, you get $16 per ticket as the fixed cost per unit. Do the same thing at the 3,300 ticket level, and it's $14.55. So don't let this confuse you. A fixed cost is a cost that does not change as the level of activity changes. Now, the fixed cost per unit will change because the more units you have, like here, more tickets you have, you're spreading that same cost, that fixed cost, over more units, more tickets, and therefore it drives down the fixed cost per unit. Okay, now let's look at the variable cost. It's just opposite. In this situation, they might arrange with the band and tell the band, we will pay you $16 per ticket. And so, depending on how much you get paid will depend on how many tickets we sell. So at the 3,000 ticket level, if you have that many sold, and you're going to pay the band $16 per ticket, $16 times 3,000 is $48,000. You think, well, what changed? Nothing changed. Let's look at the other levels though. If we go up to 3,300 tickets, at $16 per ticket, we will pay the band $52,800. So this cost went up. If you sell fewer tickets, you're going to pay the band less money. So this is a true variable cost. The total changes as the level of activity changes. Now the cost per unit, here in this case per ticket sold, does not change. It's a variable cost per unit. It's always going to be $16 per ticket in this case. But the more tickets you sell, the more money you're going to pay the band. So this is a true variable cost. Now let's look at some graphs. This is for the fixed cost behavior. For total fixed cost, if you're going to graph it, it's the reddish line here, dollars, units, then it's the same dollar amount no matter how many units you have. That's the total fixed cost. Now, fixed cost per unit, as we saw before, the more units you have, the less fixed cost per unit there is. So this is the fixed cost per unit line. This is the total fixed cost line. For variable cost, here, if you don't sell any tickets, you don't have any cost. It's zero. But then total cost-wise, for variable cost, the more tickets, the more units you have, the more you're going to pay the band. Variable cost per unit stays the same. We're going to pay the band $16 per unit, no matter how many units that we sell, how many tickets we sell. So the fixed cost per unit stays the same, but the total, the variable cost per unit stays the same, but the total variable cost will differ here. So total variable cost per unit. Now in mixed cost, here we have a cost that is part variable and part fixed. So they're talking about cleanup after the concert, and they have agreed to pay a janitorial service, $1,000 flat rate, plus $20 per hour required to do a cleanup. So we have a base fixed fee, that's the fixed cost part, $1,000, and then $20 per hour afterwards. This is the variable cost portion. So how much would the total cost be? Well, it depends on the number of hours. So if it takes 60 hours to clean up the concert venue, the total cost is going to be the fixed cost of $1,000, that's the flat fee, plus the variable portion, $20 per 60 hours. And so multiply all that out and add $2,200. If it takes 90 hours for the cleanup, the total cost will be $1,000, this is still the fixed portion, plus 20 times 90 hours in this case, and so the variable cost would go up, add that to the fixed cost, so it's $2,800 for this total mixed cost. Okay, so you can read through here yourself. These are examples of mixed cost. And the relevant range, if you had economics, you probably covered this also, but any cost keeps its character within a relevant range. So cost is fixed only within a relevant range because at some point you have to add capacity, which might make the total fixed cost increase. So anytime we are talking in this course about fixed cost, variable cost, or mixed cost, it always happens within a certain relevant range of activity. Okay, so I'll let you read that yourself. Let's look at the next page. Now, operating leverage. This concept is sometimes a little difficult to understand, and it's sort of difficult to explain also. So let's go through this sort of slow. I'll try to explain it the best I can. Now let's just see what the definition is first of all. Click here. Operating leverage. Cost structure condition that produces a proportionally larger percentage change in net income for a given percentage change in revenue. It's measured by dividing contribution margin, we'll talk about that in a minute, by net income. The higher the proportion of fixed cost to total cost, the greater the operating leverage. Let's keep that in mind. We'll chart here. So if we have a small percentage change in revenue and we are highly leveraged, operating leverage wise, we're going to have a dramatic percentage change in profitability. Let's see how this works. Let's go back to the ticket venue again. Let's say we're going to sell tickets for $18 per ticket. Let's look at the middle one first. If we sell 3,000 tickets, revenue is 3,000 tickets times 18 per ticket, $54,000. The cost of the band, we're going to go the fixed cost route in this example, $48,000. We have a gross margin of $6,000. And gross margin is similar to gross profit that you probably had in the first course. So, total revenue minus total fixed cost, we have gross margin $6,000. Now, if sales go up 10%, so if we sell an extra 300 tickets, we now go up to 3,300. 3,300 times 18 per ticket, 59,400. Our revenue goes up quite a bit, 10%. Fixed costs don't change. Look what happens to gross margin. It went up from 6,000 to 11,400, a 90% increase in gross margin. So look at this. Sales went up. Sales revenue went up 10%. Gross margin went up 90%. See, that's leverage because we have a lot of fixed costs here. In fact, our only cost structure is fixed right now. Look what happens though if you drop in volume. Let's drop 10%. So we don't sell 300 of those tickets. So only 2,700. Revenue drops to 48,600. 2,700 times 18. Fixed costs don't change. Look at our gross margin. we drop all the way down to $600. So a 10% drop in revenue, activity, revenue, equates to a 90% drop in gross margin. So it can work both ways here. If you're highly leveraged, it's great when activity and revenue goes up because your profit goes up a lot, but the opposite happens. You drop off in sales, your gross margin drops down quite a bit. So I'll let you read through this, and this is just saying that having fixed cost, there's a risk. Because if you don't make the revenue, you don't make the sales, you still have to pay for those fixed costs. So there's risk involved. One way to lower the risk is to have variable cost. Because if you don't have those extra units, you don't have those extra variable costs. So let's see how that works. Let's go to the strictly variable cost situation. So we're going to pay the band $16 per ticket sold. At the 3,000 unit level, 3,000 times 16, $48,000. Revenue, 54, $6,000. Same thing we were right here, 6,000. See? The only difference is this is now a variable cost of the band, as opposed to fixed cost. Let's go up 10%. There's the revenue going up 10%, but the cost of the band also goes up. So now we have 3,300 times 16. We're up to 52,800 here for total cost. Our revenue only goes up 10%, 6,600. A stark difference here. Let's look at this again. Here, revenue went up 10%. Only fixed cost, they don't go up. The profit, the gross margin here went up 90%. If you have all variable cost, look what happens. Your profit only goes up 10%. It's not as risky, but the leverage isn't there. Your profits are not going to go up as high. Now, they also don't go down as quickly if your sales drop off. Drop 10%, revenue drops 10%, costs drop also, variable cost. Our gross margin, 5,400. Now, this 5,400 looks a lot better than this 600 right here. Okay? So again, it's risky here. If things work out to the better, great. But down here, if you're not highly leveraged and things drop off, you're not hit as hard. So it depends on how you want your cost structure to be. This is a decision you'll need to make, for your company. So that's the effect on operating leverage. The more fixed cost you have, the more highly leveraged you are. This is a 9 factor on leverage. 10%, 90%. Revenue goes up, profit goes up even a larger percent. Not highly leveraged, like a 1-to-1 kind of situation here. Sales go up 10%, profit only goes up 10%. So here's another example. We have 3 different companies. They have different cost structures. So we have company A that does not have any variable cost per unit. For each company, the sales revenue is $10 per unit. For company A, no variable cost, fixed cost of $60, we have a profit of $40. Company B, we have $3 variable cost per unit. So when you sell 10 units, 3 times 10, $30 variable cost. Fixed cost will be $30. So subtract out, and $40. C, we have $6 per unit for variable, no fixed cost. So if you sell 10 units, $6 times 10 is 60, subtract 40. So you think, well, there's no difference in having cost structures of different amounts, fixed or variable. Well, again, it does make a difference, and we'll see that difference as you change things. Let's look what happens when you sell one more unit. So we sell 11 units. So revenue goes up, $110 for A. Variable cost, we don't have any. Fixed costs stay the same. So when you sold one more unit for $10, look, it all goes to the bottom line. Look up here. This is the same set. This is A up here. When we sold 10 units, $40 was the net income. Here, you sell one more unit, it all goes to the bottom line. we don't have any variable cost. For B, remember we had $3 per variable cost. So one more unit, revenue is still the same for all these companies. But the variable cost increase, $3 compared to before. Fixed costs stay the same, and we have $47. We did have 40, we only have 47. We had some variable costs we had to cover, and that came out of the sales and hit the bottom line. Let's look and see what happens when we don't have any fixed cost again. $6 variable cost per unit times 11, 66. Subtract $44. So again, you have more variable cost as you go across, less fixed cost. There's less risk with C, but there's less reward also if things go well. Let's see what happens when things go the other way. Let's drop a unit. So now everyone has sold 9 units, $90 revenue all the way across. No variable cost for A. Still have 60 to cover. We're at 30. B, we have $27 in variable cost. 3 times 9, 27. Fixed cost of 30. We have 33 in profit. And in C, $6 times 9, 54. No fixed cost, and 36. So you can see you're better off if sales dropped off having variable cost. But if sales go up, you're better off having fixed cost. So again, this is for, what do you want for your company? How much risk do you want to have in your cost structure? The more fixed cost, the more risk. But if sales go up, more reward. If you have more variable cost, there's less risk. But when sales go up, there's not quite the reward. But if sales go down, you're not hit as hard on the bottom line. So read the rest of this yourself on this page. Let's go to the next page. Here is a contribution margin format for an income statement. We have variable cost per unit, and we have revenue here coming in at 200. We have Bragg and Biltmore. So variable cost, 10 units times 6, 60. 10 units times 12, 120. Contribution margin. Contribution margin is defined as, it's revenue minus variable cost. Let's see their formal definition. The difference between sales revenue and variable cost. That's the amount available to pay for fixed cost and thereafter to provide a profit. So a new definition, contribution margin is equal to revenue minus variable cost. Contribution margin is not the same thing as gross margin or gross profit. It's strictly defined as sales revenue minus variable cost. Take away your fixed cost, and there's your net income. I've looked at these examples before on this page. I don't care for these examples that much. Go ahead and read through these yourself. Again, I don't like these, so I'm not going to go through these step by step. Let's go to the next page. Now let's finally see how we compute operating leverage. Okay, we saw earlier that the magnitude of operating leverage is contribution margin divided by net income. So they're getting these numbers from, let's go back to the previous page, right here. Net income, contribution margin. We're going to use those numbers to compute the leverage. And so if we divide contribution margin 140 by 20, the contribution margin is 7. For Biltmore, 80 by 20, it's 4. Now remember, 7 and 4, let's go back. Back here, look at this. We have more, let's get this straight here. We have more fixed cost for Bragg. Therefore, we're going to have more operating leverage, that magnitude. Again, 20 divided into 140 compared to 20 into 80. So you can see this is 7, this is 4. How do we apply this? Well, let's look at Bragg. If Bragg's revenue goes up 10%, the variable cost for its structure goes up by another 10%, 66. Contribution margin, will also go up because, of course, revenue went up, variable cost went up. Fixed cost stays the same, and so we have a jump from $20 net income to $34. 70% of 20 is 14. It's going up 70. Add the $14 to 20 to get 34. You can take 20 times 1.7 to get 34. So you can see easily, once you know, I'm going to scroll up a little bit right here. Once you know the magnitude of operating leverage for a company, for Bragg in this case, 7, you will know that if you can increase revenue 10% and your cost structure stays the same, variable fixed, your net income will go up 70%. So a 10% increase in revenue will equate to a 70% increase in net income. Now for Biltmore, it's not highly as leveraged. When you look through the numbers, sales go up 10%, net income goes up only 40%. Okay. Again, less risk, but less reward as things increase, activity increases. Next page, let's see what we have, cost averaging. This is not a great example here either. I'll just talk about it a little bit. Let's say you have a water skiing company, you give lessons, and you have a lot of variable cost here. You rent the equipment, for the day. Instructors paid $15 per lesson hour. Fuel cost $2 per lesson hour. Lessons take 1 hour, and the company can provide up to 20 lessons in a day. I guess they have 2 or 3 boats, they might rent or something. Let's see how we put this in the numbers. They say that on Friday you only had 2 lessons. Well, that's not very many. If you add up all the cost, even with 2 lessons, this 80 is going to be the same per day and per level. Instruction does vary. It's a variable cost. Fuel varies. But total cost for Friday, $114. If you give only 2 lessons, that's at a cost of $57 per lesson. You need to make a profit. This is just to cover your cost. So how much are you going to charge people who come take a lesson on Friday? Are you going to charge them $70, $80, $90 an hour? Start to get on the high side. Look at Saturday. If you give 10 lessons on Saturday, you have the equipment you rented, you have more instructor hours, more fuel, $250 higher cost, but divide by total lessons, $25. So you have some costs in here that are fixed, some costs that are variable. The more units you have, the more lessons you have, the less per lesson for the cost here. On Sunday, it's only $21 per hour, your cost. So should you charge the people on Friday a lot more per hour lesson than on Sunday? If you do that, people are not going to come Friday anyway. Everybody will come here on the weekends. So this whole area about cost averaging is just over a period of time, see what your costs are going to be, not just day by day, but a week, a month, they even do it a year at a time. What are our total costs for the whole year, let's say? What's going to be the total activity for the whole year? Find the cost per unit and use that to determine your price, how much you're going to charge people. So it doesn't matter if it's going to be on a Friday, Saturday, Monday, Wednesday, whatever, then you're going to be charging the same per hour for the lesson, because overall, when you take the whole year in consideration, you're going to get your cost covered. So, all right. So there's something else you can read. Next, HighLow Method. This is an interesting area. You will use the HighLow Method when you have a cost that is partially fixed and partially variable. This is a very simple way to divide out and find out how much is the variable cost per unit and what is the total fixed cost. The HighLow Method, just like the name sounds, very simple. Find the highest level of activity and the lowest and just use those 2 data points. So I'm looking for a high. Here's 34. Nothing's higher than 34. We're going to use 34,000 units and $540,000. That's the high point. The low point, I'm looking, there's 10, and 10's the lowest here in May. Use 10,000 units and $180,000. So use May's numbers, December's numbers for the high-low method. The highest, the lowest, ignore everything else. This is really a very simple way to divide variable and fixed cost. And here's what you do. The variable cost per unit is the difference in your total cost divided by the difference in volume. So remember, we had $540,000 at the high point with 34,000 units. At the low point, $180,000 in 10,000 units. Subtract with 360, 24, divide. $15 is what you're going to use for your variable cost per unit. Once you have this, you can find out, then what is my fixed portion of the total cost? Well, fixed cost plus variable cost will equal total cost. If you now know that, and you can switch this around, you can take this, subtract from both sides, and it comes over here, just simple algebra. So now fixed cost will be equal to the 540 total cost minus the $15 we just computed times 34,000 units for the high point, because you're using the high cost here. So 540 minus this gives you $30,000 for your fixed cost. You could do the same if you wanted to use the 180 and the 10. Put 180 here, put 10,000 units here, you still get $30,000. Now what is this used for? It's used to estimate cost. So now if you think you're going to sell 22,000 units, books in this case, what's going to be your total cost if you sell 22,000 books? Well, it is your fixed cost you identified plus $15 per unit, 22,000. Multiply this, add, so $360,000 will be your total cost estimated for that level of activity. This graph here, this is a scatter graph. All those points, when you're looking at units and dollars, you plot these in and just draw a line through here. I'm not going to have you do that on the test. Just know what a scatter graph is. Just click here, method to estimate variable and fixed cost by plotting cost on the data, drawing a line. You're not going to have to do it, just know what it is. There's another one. And let's get down to regression. I'm not going to have you do the regression model on the test. Just know that this is another way to estimate cost, how they act and so forth, variable and fixed. And it's really quite accurate because you take all the data points into consideration. It says it's a technique used to draw a line through a data set by minimizing the sum of the square deviations between the line and the points in the data set. What this means is you have software programs that do this, or you can do it by hand if you want to, but a method to get a regression model that shows you here's the fixed cost, here's the variable cost per unit, for the equation, and it's a fairly accurate way of doing that. So see, we're not going to get into this on the test, so don't worry about that. All right, we're to the self-study review problem, so that's about it for the material in this chapter. As always, go back and reread the chapter. Read it yourself, word for word, follow through with all the numbers and the examples. So, as always, good luck with your studies.